Okay, in this video, we're going to review the reflexive property. This is something you have learned before. The reflexive property is just like looking in the mirror. It looks like the word reflection. This is a rule that says that anything equals itself. So just like when you look in the mirror, you're looking at an exact copy of yourself. In geometry, we are talking about lines and angles or segments or triangles that are equal to themselves. So we learned this formally before in the shorthand for saying it was just putting A equals A, or side AB is congruent to side AB, or angle C is congruent to angle C. So you have the same thing on both sides of your congruent sign. Okay, so in the diagrams below, we're going to look for anything that could use the reflexive properties. So what you're going to look for is anything that has two shapes that share a side or an angle. Okay, so in this very first one, you can see that these two triangles share this side BD. So I'm going to write side BD is congruent to side BD. That's what we're going to write when we write our proof to show that that side equals itself. Okay, the next one, if you want to go through real quick before I give you the answers, see which ones of these have where you can use the reflexive property. Number 3 is the next one. Both of those triangles have side BD, so once again, you can write BD is congruent to side BD. These don't share anything, these don't share anything, these don't share anything. This one, it shares something again. This one would look like PR is congruent to PR. Okay, so all of these had the same side. There's not anywhere they use the same angle. That's not something we're going to use that often in this chapter. We're going to do it more with similar triangles, but an example of using the reflexive property where the angles are the same. If I have a triangle like this, it could share an angle. This angle right here is shared between the little triangle and the big triangle. So if I name this A, B, C, D, E, we could write angle A is congruent to angle A for that one. But we're not going to have pictures that look like this until we talk about similar triangles. Okay, the other thing I want to focus on this page is get a different color. Vertical angles. So you might remember way back from chapter 1 that vertical angles have to be congruent. Vertical angles are congruent. So both vertical angles and the reflexive property are something that they won't necessarily give you in the given information for the proof. It's something that you should be able to tell is true from just looking at the picture. So I can tell that these two triangles share a side. These share a side. Vertical angles, remember, are when you have it, two lines intersecting, the angles that are opposite each other are congruent. And when you're looking at triangles, vertical angles will always be in pictures that look like a bow tie. Okay, so the first example would be number 2. This looks like a sideways bow tie. The two vertical angles are here and here. You're going to have to use 3 letters to name these angles because there's too many angle C's. So remember, to name an angle, you got to remember you're connecting the dots. I could either go ACB or BCA. I'm going to say angle ACB is congruent to angle DCE. Okay, let's go. Let's hear the next bow tie is number 4. So that would be angle PRQ is congruent to angle TRS. Okay, we're going to skip this number right here. That's number 5. This is not a bow tie. Doesn't share anything. Number 6 is a bow tie. So I'm going to put angle JLK is congruent to angle MLN. Number 8 is not a bow tie. Number 9 is a bow tie. So once again, angle PRQ is congruent to angle SRT. Okay, so the two that we haven't marked yet, there actually isn't anything that we can tell looking at the diagram just based on the information they gave us. I can assume the A, C, and D are collinear, but that's not really anything I would necessarily need to put in a proof. So I'm just going to write none because there's nothing that we can tell on top of what they give us and the given for each of those.